In this video, you will learn about an important topic of data science called data visualization. Nearly in every industry, there is a huge volume of data emanating from various digital sources. Needless to say, the challenges in the analysis and study of such huge volume of data. It is not easy to analyze data in the form of numbers. The pictorial form of data is easily understandable rather than huge numbers of numerical data. So, there is a need of data visualization. Data visualization is a communication of data in a visual manner or turning raw data into easily understandable pictorial representation. It gives intuitive understanding of data and helps to see information in certain meaningful patterns. Also, visual representations enhances the human cognitive process. There are four basic presentation types that you can use to present your data. A comparison chart sets two variables against each other and displays the interaction between those two variables. For example, a line chart displaying the variation of values over a given time period. A composition chart displays how individual parts make up the whole of something, like a pie chart. A distribution chart helps to understand outliers, the normal tendency, and the range of values in the dataset. A column histogram displaying the distribution is an example for this type. A relationship chart tries to show a connection or correlation between two or more variables, like a scatter plot. There are many ways to present the data and countless chart types are available. However, when making sense of facts, numbers, and measurements, a better understanding is required and is important to design the right visualizations for your data. Often, the most important or the difficult part of creating a data visualization is figuring out which chart type is best for the task. The choice of chart type depends on multiple factors like how many variables to be shown in a chart, how many data points to be displayed for each variable, what relationships you try to understand from the data, are you looking for distribution of data and outliers. Temporal visualizations are one of the simplest ways to represent time series data. Charts are called temporal only if they are linear and one-dimensional. Examples include line charts, area chart, bar charts, and scatter plots. In multidimensional data visualizations, there are always two or more variables in the mix to create a 3D data visualization. Examples include pie charts, scatter plots, histograms, and Venn diagrams. Before we look into the Python code to plot the charts, let us know the dataset. The dataset which we discuss in this video will be the iris dataset. The features in this iris dataset are sepal length and width and petal length and width, all given in centimeters, and targets three classes of iris flowers: iris versicolor, iris setosa, and iris virginica. The data can be downloaded from the UCI machine learning repository. The dataset can also be imported from sklearn library in Python. First, let us try to import the basic libraries like NumPy and Pandas. Next, download the dataset and read the downloaded dataset location using Pandas read_csv function. Now, print iris function prints the dataset, the rows being the samples and the columns being the features of the iris flowers. Now the function head will display the top rows of the dataset. The default value of this function is 5 when no argument is given to it. Here are the top 5 rows with the features of iris flowers. Similarly, a sample function can be used to display the rows randomly. This is how you can read a data set in Python. Before plotting the different graphs, let us try to see each plot's types in detail. Line graph is used to plot the relationship or dependence of one variable on another. Line graphs are drawn first by plotting data points and then connecting a line between all of these points. Typically, the y-axis has a quantitative value while the x-axis is a sequence of intervals. The direction of the lines on the graph works as a metaphor for the data. An upward slope indicates where values have increased and a downward slope indicates a decrease in values. So the line reveals the trend in the dataset. Avoid using more than 3 to 4 lines per graph as this makes the chart more harder to read. Instead, divide the chart into smaller multiples called subplots. Now the question is when to use line plots. The best use case for a line plot is when you have a continuous data set and interested in visualizing data over an interval of time. First, let us try to plot how the feature sepal length varies for all classes in the dataset. Okay, before doing that, let us try to import a library called matplotlib as PLT. This library is used to create the plots in Python. So the function plt.plot will create a line plot in Python. So iris sepal length indicates the feature. So this shows the feature sepal length, how it varies for all classes in the dataset. So giving a proper title, X label and Y label for the chart, it looks like this. Let us try to plot two features in a same plot. So let us consider the petal length and petal width. So this plot compares two features for all classes of iris class, petal length and petal width. The next type of plot is a scatter plot. Scatter plot shows the relationship between two variables of a dataset. Various types of correlation can be interpreted through the patterns displayed on scatter plots. The strength of the correlation can be determined by how closely packed the points are to each other on the graph. Points that end up far outside the general cluster of points are known as outliers. Scatter plots are ideal for paired numerical data and to see if one variable impacts the other. Let us plot iris sepal length in a scatter plot. So plt.scatter will plot a scatter graph in Python. Let us draw a scatter plot showing how a petal width changes with change in petal length. So considering the two features, okay, the graph looks like this. We can observe that there are some petals which are smaller than the rest of the petal. Similarly, visualizing multidimensional data can also be done in scatter plots. So first, let us try to create a figure in a 3D projection and then creating a plot with petal length in the x-axis, petal width in the y-axis and sepal width in the z-axis. So the graph is shown like this, which displays the variation of petal length and petal width and sepal width in a three-dimensional view. The next type of plot we are going to discuss is area chart. Area graphs are used to display quantitative values over an interval or time period. Area graphs are line graphs, but with the area below the line is filled with a certain color or texture. The best use case for an area chart is when you want to see how different items stack up or contribute to the whole. Now let us try to generate area chart for the class iris setosa. The first 20 values of the samples are considered for the plot. So this is the area chart for the first 20 values of iris setosa. This type of chart is called as stacked area chart. Let us try to plot the area chart for the entire data set. So taking the entire data set, the plot.area is a function that is used to plot the area chart. Let us continue with other types of graphs in the next video. Thank you.